Greetings and welcome, Mr. Waddy here. And so we've solved systems of equations when we've had two lines. We've solved systems of three equations, which is three separate planes in three-dimensional space intersecting. And now we're going to do a new thing. We're going to solve systems of equations where maybe not everything is a line. And in this case, we're only going to be looking at systems of two. But here we go. We're going to have quadratics and lines. And so here's an exploration solving non-linear systems of equations. And so this first one is a classic right side up parabola with a vertex at 0, 0. So it looks like this right here is the only one that works. And then y equals x plus 2 would have a slope of 1 and a y-intercept of 2, y equals mx plus b style. And so notice slope of 1, a y-intercept, y-intercept of 2 I marked in red, and then a slope of 1, up 1 over 1, up 1 over 1. And so as a result, you can identify, these two graphs, and the solution, plural, would be the places in which they intersect. And so this solution would be like 2 comma, it looks like 1 2 3 4, and this solution would be negative 1 1. Although in this case it doesn't look like we have to find the solutions, we're just trying to match, and so A goes to A. All right, here we go. Here's another, the second equation is a line again, same line as that one. And so it looks like this, and y equals x squared plus x minus 2. That factors to be an x with a 1, x with a 2. And I'm thinking about this as far as x-intercepts of this parabola, and I know it's a parabola because of the squared. And so it would be what? Minus 1 plus 2? And therefore the x-intercepts would be at positive 1 and negative 2. And so notice positive 1 and negative 2 there. And so this is represented in the graph E, and the solutions would have been the places in which they intersected. Good. Over here, y equals negative x plus 1 is a sloped down line. So I can tell that this is going to be f by default. And this one is not factorable, and so the x-intercepts, notice, pass through decimal values. It does open up, and so yeah, I think I've, through process of elimination, already matched that to f. Here I'm going to have an open up and an open down parabola. This top one factors to be x minus 2 times x plus 3, and so it would have had opened up, x-intercept at positive 2 and negative 3. So opening up, positive 2. Oh, whoa, look at this. They're changing the scale on us. So positive 2 and negative 3. Yeah, it's this right here. What do you know? And this one is a negative open down parabola, which happens to have the same exact intercept. So this one matches B after a little bit of analysis. Ooh, now this factors to be x minus 1 all squared. And so there's only a single x-intercept, which is at positive 1. So it's a ricochet graph. And this one happens to be the upside down version of that. And so this one, as far as solutions go, notice this one had 2. This one 2, 2, 2 here. The solutions are where they intersect. This one would have only had a single solution, and so that does happen at times. E matches Charlie. Let me grab a little sip of water here. There we are. And Foxtrot. This one has is not factorable. Wait. Waddy, what are you saying? That's x plus 1 all squared. What am I saying? I thought it was going to be above the x-axis, but no, it does intersect at negative 1. So it's the blue graph right there. And then this one here, if I factored out the negative 1, would have been x squared minus x minus 2. And so that would have factored to be negative 1 times x minus a 2 and x plus a 1. And so the intercepts would have been at positive 2 and negative 1. And yeah, it's this one here. And so this matches graph D. And so graphically speaking, if you remember how to graph your parabolas, then yeah, you'd be able to just graph these things and find the intersections, and it wouldn't be bad. Technology is also good at making this very, very functional. And so here we go. Systems of nonlinear equations. That was the exploration. It's probably enough that you could figure out how to do most of this. At least the solving by graphing part, which the first example is. And so previously, you solved systems, blah, blah, blah. All right, we're going to solve nonlinear equations. Boom. A few different things could happen. You could have no solution if there's no intersection. You could have one solution. Look at that. That's called a tangent line, by the way, when it hits at exactly 1 point. You could have two solutions occur. Oh, wonderful, wonderful. If you got two parabolas, you could have no solution, one solution, two solutions. Now, technically, if you allow for non-function sideways parabolas, you could have something crazy like this with 4 solutions. But in this class, we haven't done any sideways parabolas, so don't worry about it. Forget I mentioned it. Here we go. Example 1. Solve the system by graphing. Tell you what, I'm in a liney mood today. So for the line, m equals -2. The y-intercept, b equals -1. I'm thinking y equals mx plus b. And so here's -1, the y-intercept, moved by my slope, which is down 2 over 1, down 2 over 1. Plot those points, draw the line. Do I have my line tool equipped? I haven't drawn lines in so long in... Wow, we've been doing like quadratic stuff for so long. I haven't needed the line. And so, oh, let me make this purple. And so here's the line. Okay. Beep 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 beep. As far as the parabola, I happen to look at this and realize that it's factorable. So I'm going to factor that. So I'm going to have the factors of C are 1 and 1. No, it isn't factorable. No. All right, then tell you what, let's do the ABC thing. So A equals 1, B equals -2. This is in standard form, that's why I'm thinking that. As far as finding the vertex, the most important point, you might remember that you could use the little formula, -b over 2a. It's been a minute, hasn't it? Yeah, been a while. And so here we go. The opposite of -2 is 2 over +2 equals 1. And so I know that h equals 1. Let's find k, which I could find by plugging in 1 for them x's. All right, and so I'm going to get x squared minus 2x minus 1. And I was plugging in 1 for the x's. And let's figure out what k equals to. 1 minus 2 minus 1 equals a -1 minus 1 is -2. And so, guys, wait a minute. It opens up. No, I don't think it's factorable. So let's see. It just must pass through at decimal values because it's not factorable. But it still has some real answers. So my vertex is over 1, down 2. And since it opens up, I can move by my slopes. Since the value of a is 1, my slopes, and this, if you haven't watched a Wadi Math video on how to do slopes of a parabola, you should check it out. The slopes of a regularly shaped parabola, all of the rises happen to be the consecutive odd numbers, 1, 3, 5, 7, 9. And so from the vertex, go up 1 over 1, up 3, backwards 1, and we can see that, yeah, we'll cross the x-axis at a decimal value and go from there, and then up 1 over 1, up 3, backwards 1, and go from there. And I'm probably not going to draw this perfectly, but it turns out, oh man, that's garbage. It turns out the solution, it only has one intersection. And so the solution happens to be the point 0, -1. And let me remind you what a solution is of a system again. It is the combination, x and y in this case, x, y, z if it had 3 variables, that makes both of the equations true at the same time. And so this has, if I plugged it in for those, it would check out for both of them at the same time. All right, and so solving by graphing, as long as you remember how to graph, it won't be that bad. It could be a little tricky if your graph, if they intersect at a weird decimal value. It would be tough to do that graphing by hand, but that's when technology would help you out. Now, it is also possible to solve algebraically. And so up here, I've got a parabola written in some non-standard form, and here's the equation of a line. I know this is the line because it doesn't have a squared term. And so if I want to solve by substitution, I can do so by solving any of the equations for any of the variables and plugging in. This one would be a little bit tricky to solve for x, because it's like quadratic-y and there's 2 terms. I think technically you could. I'm interested, I think, in solving this equation for y. It's got a coefficient of 1, right? Technically, all of these have coefficients of 1 or -1. They all could technically work. But I think solving the second equation for y will be easiest. And then when I plug in, I'll end up with a revised equation and a quadratic, and I'll have to solve that by factoring or completing the square or something like that. So to get this y by itself, I get y equal, all right, let me write this over here. Y equals -x plus 4 is what I solve for y, and now substitute. And one of the other reasons why solving for y was nice was that I didn't have to then plug in whatever x's expression would have been in multiple locations. And so I'll have x squared plus x minus, super careful with parentheses. Look out, look out. -x plus 4. Let's distribute x squared plus x. Distribute the minus sign. Double negative becomes positive, and -4 equals -1. X squared plus 2x minus 4 equals -1. Now, as I size this up, I could solve a quadratic equation using factoring, the quadratic formula, completing the square. If I was to solve by factoring or quadratic formula, I would have added 1 to both sides, and I would have gotten a -3 here. And would this have been factorable? Well, the factors of 3 that subtract the 2, it is factorable. And so that's a great strategy for solving this. I think I'll do that. Now, the fact that the leading coefficient was 1 and the b term was even, completing the square would have been fine too. So when I factor this, and you guys, of course, are expert factorers these days. So the factors of 3 are 1 and 3. They got to multiply to be 2, or they multiply to be negative, and so their signs are different. They add to be 2. So the 3 must have been the positive, the 1 must have been the negative. And then when I solve, I get x equals +1, and x, oh, I forgot to write my x there, x equals -3. Now, this is new to us. I've got 2 values of x, and I'm looking for a y. Now, what this means as far as solutions go is I'm looking at a 2-solution scenario, and these are just both of the x coordinates. And so in order to solve for the whole point, I'm going to need to plug this in and solve for y. This looks like a great place to do it. Technically, you could do it here. Technically, you could do it there. But this one's already solved for y. So why not? Here we go. Let's see. Plugging in the 1. Y equals -1 plus 4. Y equals 3. And so I get 1, 3 is one of my solutions. But look out, I got 2 solutions. So let's substitute this twice. And so y equals the opposite of whatever x is, +4. X in this case is a -3. I get y equals 3 plus 4. Y equals 7. And make sure you match the correct x's and the correct y's. So 7 occurred when x was -3. And so there's my solutions, plural. Wonderful. Thing of beauty, right? Good, good, good. Let's keep going. Example 3. All right, now this is a little bit weirder. I've got double parabolas. Solve by elimination, though. Now, if I was to solve by substitution, I would have probably solved for one of these x's. Solving by elimination, they actually did me a huge favor here. If I call this equation a and b, now I could technically try to find opposite squared terms, or opposite x terms, or opposite y terms, etc. And in this case, I realize I already have opposite y's. And so to do elimination method, I'm just going to add a and b, and I'll eliminate my y's. I'll have an equation only written in terms of x's, some of them squared, and then I'll be able to solve that. And so here we go. 2x squared plus x squared is 3x squared. Negative 5x plus 2x is minus 3x. The y's were eliminated, and then negative 2 plus 0 is negative 2. Now, ooh. Okay. I was wishing I could, if this was set equal to 0, I could have just GCF'd and solved, but it's not. And it's got a leading coefficient, and this isn't divisible by 3, so I can't just divide everything by 3. So I'm going to set this equal to 0, and it's looking like quad form is the way to go. So 3x squared minus 3x plus 2. Man, this section is a boss fight. It's pulling back solving systems. It's pulling back factoring and solving quadratics. This is a whole bunch, like this is almost the whole course. Like this one section is practically your final exam if I had it, right? And so here we go. I'm going to now quad formula this. I don't want to complete that square. Let's check factorable. Tell you what. Let's check factorable. And the reason why it's likely going to be factorable is, well, to be honest, I'm kind of be giving you friendly problems, I'm pretty sure, where they happen to have nicer answers, because I wouldn't want you to have to plug in weird square roots in for x to solve for y. I could, but let's check, because we haven't AC methoded in a while. So 3 times 2 is 6. No, and there aren't any factors of 6 that had to be 3. All right, it's quad form. A equals 3, B equals negative 3, C equals 2. Let's see here. I'm just, because earlier this week I'd recorded a video where I just made a huge mistake early on, and it was annoying. Okay, I have not made a mistake yet. I scrolled down in my notes just to see. Normally I just wing it, but I got scared. So here we go. Quadratic formula. X equals the opposite of... Oh, guys, you don't need me to sing the whole... You don't need me to write it out. You know the whole thing. Here we go. Let me just do it. X equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And let's see, opposite of negative 3 is positive 3. So guys, I've got bad news. This is going to actually have ugly answers, but it happens. Quoting Patrick, I mean, are you afraid to look ugliness in the face? It happens. Negative 12 times negative 2, that's 24 of the positive, all over 6. And I get 2 x values, which are 3 plus or minus the square root of 33 sixths. And so those are my x values. And now, wait a minute. Guys, made a mistake. Wait a minute. Did I? 3, negative 3, bop, right here. Look at it. Look at it. Look at it. This was an equal sign at one point, and it looked like a negative sign. C equals positive 2, which was enough to do this. This is positive. And therefore, this is negative. And therefore, this, my bad, is negative 15. It's all right. You can learn from my mistakes. And so, since this is negative 15, therefore, this means this has imaginary Imaginary answers, imaginary roots. And if graphically speaking, the intersections are imaginary, then that means that there is no solution, no real solution. All right. So these two parabolas, they just don't intersect with one another. And that happens. It can happen, friend. Yeah. Actually, let me just show you visually what's going on here. I'm opening up a Desmos. Let's reverse contrast. Boom. Projector mode. Bam. 2x squared minus 5x minus y. Oh dear. Minus 5x minus y equals -2. You get one parabola. And then, oh dear. Where was the other? X squared plus 2x plus y. X squared plus, come on. There we go. Plus 2x plus y equals 0. There we are. And so notice, those graphs, they don't intersect. Never touch, no solution. There we are. Okay, that was a little scary for a minute there. I was like, uh-oh. I thought, yikes. I thought we were going to get real solutions, and then I'd have to plug this in and solve for y. Oh, that would have been miserable. But technically achievable. Anyways, all right, I've got a couple monitoring progress questions I can have you take a look at. Solve the system using any method. Hey, look at this. When these are both solved for y, and these ones, this is a parabola, this one's a line. This one's not a bad one to solve by graphing because it's both y equals, and this is a super friendly parabola. It's not a bad idea. If I was to use substitution, the fact that both of these are already solved for y makes it a little bit nice. Actually, tell you what, we'll plug this one in over here. And I would have had -x squared plus 4 equals -4x plus 8. I could bring these on over here, -x squared plus 4x. All right, let me write this down so I don't make a sign error, right? And so this 4x didn't have any other x term to combine with. And then subtract 8 from both sides. 4 minus 8 is -4 equal to 0. And I'm going to just opposite both sides of this equation just to make things nicer. X squared minus 4x plus 4 equals 0. And that, I believe, is factorable. That looks like x minus 2 all squared is what you'd have ended up getting equals 0. And so you would have gotten x equals +2 when you set that equal to 0 and solve. And then in order to find y, you would just take this and plug it in. Looks like that's the easiest place. And so y equals -4 times x plus 8. I'm still recording. Yeah, let's see. For Waddy, this video is getting too long. All right, y equals 0. There's another one for you. Solution is 2, 0. This one here, you could do substitution. You could eliminate, get one of those opposite y's. That one's not a bad one. This one, elimination method, just do the opposite y's. Let's add those together right now. I would have had 3x squared plus 4x. The y's would have canceled out. Equals, 0. Oh, here we go. This one's nice. This one I haven't factored using greatest common factor in forever. So I could have factored out an x. I would have had x times 3x plus 4 equals 0. This one's a little tedious. X equals 0, and then 3x plus 4 equals 0. Notice what happens here. 3x equals -4. X equals -4 thirds. And so this answer will be a little bit annoying to find its y coordinate. But you could do it. You could just plug it back in. Right, and so to find y, I'd probably use this equation. Get the easy kind of positivist y to work with. But anyways, you get the idea. You can substitute, you can eliminate, you can graph, all sorts of things. This video's been long enough. I'm going to go record the homework video now. See you then. Take care. Bye-bye.